So again, my name is Stephan Lagerholm, Secure64 Software Corporation. I'm also involved with Stan Barber here doing the Texas V6 task force, trying to get some traction in Texas around V6. We had a very interesting and good meeting just a couple of months ago with around 100 or so people, so that was interesting. So I'm going to talk about Secure64, what we do around what we do in general, and with focus on IPv6, of course. We have, it's nice to work with Secure64 because we only have 3 products, so it's fairly easy compared to Juniper or Cisco, those guys that has 50,000 different products. So I can say I know all our products pretty well, and we have 3 products: an authoritative DNS server, a DNS signer, which is a specific piece of software to very rapidly being able to deploy DNSSEC. And this is a market in the federal space, which are mandated to do DNSSEC. We have about 50% market share with this product, so it's a very successful DNSSEC product. And then we have our DNS cache, which is a high-performing DNS cache server targeted towards service providers. All 3 of our products run our own operating system called SourceT. Our founder worked with HP on the Itanium platform, and he retired in the beginning of 2000. And after a couple of years, he realized that nobody's taking advantage of all the security features he put into the Itanium processor. That he started Secure64, and we made our own operating system. So for the first 5 years of our lifespan, we were focused on just making this ultra-secure and high-performing operating system. And then, in 2006-07, we started to develop DNS as the first application on top of that operating system. So we have built IPv6 support into our product, of course, which has been an interesting endeavor for us, of course, but we now have full support for V6. We do everything we're supposed to do. There's more or less feature parity. There's a few things we can't do over V6 that we need to have V4. And when you install, there's defaults to V4 and those kinds of things. But in general, we have feature parity between V4 and V6. We're also, of course, very focused on performance. Most of our code is written, or I wouldn't say most, but a lot of our code, low-level code, is written in assembler to get a high performance. We have built-in denial of service protection, both from a V4 and V6 standpoint, so that you can block a user. If somebody's sending 10,000 queries per second, for example, you can block that user. Again, DNSSEC, full support, both from a validating standpoint in our caching product, as well as on our signer and authority product to generate the actual signatures. Blacklisting, I spoke with a gentleman from Australia at lunch yesterday. Blacklisting is something that we see in a few regions. There's mandates as far as I understand, both in Australia and in Germany, that those governments needs to install the government is forcing the service providers to install blacklists to protect their users from different type of content, basically. So that's something we support as well. And then even if you're not doing DNSSEC, we have multiple layers of cache poisoning protection. One interesting thing with IPv6 is that it opens up for new possibilities if you're creative. And one thing of doing that is you can add randomization when you send out packets. You can go from one IP address to another, so that it's hard for anybody to detect what IP address you're using. So you're adding entropy to your packets, and that's one way of actually defending against cache poisoning attacks. And that was not as easy in V4 because you have a limited set of V4 addresses. But in V6, with an unlimited number of addresses, why not just use 256 addresses, or how many you want as for your outgoing addresses, and randomize between those. So a lot of, when we look at IPv6, we do not look at just supporting the Quad A records and function of a V6 transport. Those are, of course, supported in our product, and IPv6 ready, gold certified, all of that good stuff. we already have that. But there's a bunch of other steps that you need to take to migrate from a v4 only network to a v6 only network, because that's the end goal here. We're not trying to do dual stack. At the end of the day, what we want to do is we want to do v6 only. At some point in the future, that's where we want to be. So handle IPv6 specific issues. 90%, I would say, of DNS is similar in v4 and v6, but there is this 10% difference. There's some things you can't do in v4, or you need to do them differently in v6. One example is a reverse delegation, which appears to be very complicated to implement for a service provider. So when you have an IP address and we look back and get a host name from that IP address. And I'm going to touch on the reverse delegation issue a little bit more further down in the presentation and why it's complicated. Also, features to help migrate to dual stack. We have this breakage, like Vint Cerf said in his video. We're doing whitelisting to make sure we don't break any clients. So we have some interesting features in that area as well. And then finally, what you want to look into is you want to have features to migrate away from v4. At some point in the future, whether it's when 50% of your traffic is IPv6 or whatever threshold you have, but at some point you want to be able to turn off the v4 network and say, we're done with this now. Because the cost of doing dual stack is because you need to maintain two networks. You need to have two IP address plans, you need to maintain two networks. If you can remove one of those networks, it's going to be much easier for you. So Juniper and other speakers have been talking a lot about the different transition mechanisms that's available for you. Here's just a few of them. There's probably more than this. But you can basically categorize them into 4 categories. You got the native dual stack category up there in the top left corner, I guess, right? And then you got, underneath there, you got the tunnel v4 and v6. So where you have your existing v4, you have a v6 network and you tunnel v4 on top of that v6 network, and dual stack lite is perhaps the most known technology for that. And then the other way around, the reverse, right? You tunnel v6 and v4, like 6RD. And then there's a fourth thing you can do, which is to translate. And the most interesting technology there would be DNS64, NAT64, which I'm going to explain how that works. The interesting thing is that with all those transition mechanisms, some of them, like DNS64, obviously require support in your DNS server to be able to do it. But whatever you choose here, DNS is kind of going to go from a, from a role in the background to being kind of a centralized component in your network. That's where you announce, you migrate your server to accept IPv6 traffic, and then you need to announce that. And the announcement is being made in the DNS server when you add the quad A record, and that's when you're going to get traffic to you. So DNS, and also, like somebody I think yesterday said, all of a sudden you're talking about those 32-character long, hexadecimal addresses. You don't want to deal with those manually. You can't even ping an address and try to remember, tell somebody over the phone, can you ping this IPv6 address for me? It's not going to work. You need to put everything in DNS, including your internal devices, switches, router, whatever that you have an IPv6 address on. Another interesting thing with IPv6 is that there's actually 2 outgoing DNS queries for every system call from the browser. So under the hood, if you look below the graph, the browser is calling a system function called getAddrInfo, and the operating system will then issue 2 DNS queries, one for A and one for quad A. And it's going to return a sorted list back to the caller with the IPv6 addresses on top of the IPv4 addresses in that list. So if you're a system programmer, you said it's only one system call. That's right. If you're a network guy or a DNS guy, there's actually 2 outgoing queries going out from the operating system. And this is, of course, going to be, you're going to have double, the load is going to double. Once a client turns on v6, the load is going to double from that client, because everything is not only going to be an A query, it's going to also be both A and quad A query. So what we're seeing today, and I don't know exactly why, because I don't think 5–10% of the population has deployed or is running tunnels or something like that. But today, when we look at our customers around the world, we see 5–10% quad A queries already. So it's a significant number already, and it's going to grow, and it's going to be as much as the A queries basically. So you're going to have almost a 100% growth here over the next couple of years. So in our roadmap, so again, we already have v6. You can configure interfaces, as many IP addresses as you want, and those kinds of things. In our roadmap for our caching system version 2.5 that's coming out here in a couple of weeks, we have full support for DNS64. And I'm going to explain more exactly, but it's a transition mechanism to be able to kind of leapfrog, to skip the step of doing dual stack and go directly into a v6 environment. We also have this disable quad A on v4 transport functionality. Again, I'm going to explain details about it. For some people might have heard of it as the Yahoo hack, because it's a gentleman from Yahoo, Jason Fessler, and another guy that I forgot the name of, that actually, Igor or something, that actually proposed this initially. So this is a way for service provider to make sure that they don't cause this breakage that Vint Cerf was talking about in his video. We're also looking into the reverse delegation. Reverse delegation in v6 is very complicated, because in v4, usually what you do as a service provider, you take all your addresses, you just put them in DNS so that there's a reverse mapping between an IP address and a host name, because that's required from an RFC, that you need to have that mapping. In v6, that doesn't work, because if you have, /64, that's, a gazillion of addresses, you don't have enough memory to do it that way, to pre-populate the reverse tree. So you need to come up with another solution. And there's other thing that complicates this even more. Service providers are doing prefix delegation, so a customer will actually get the /48 or /56 or something like that from the service provider. And how do you delegate DNS in that case? You need to do that dynamically as well, and it's not straightforward how to do that. One solution would be to use dynamic DNS, so that the customer would send a dynamic DNS packet up to the service provider saying, okay, this is my, this is the IP address I'm using, and this is the host name. But that doesn't really scale, to millions and millions of customers. So that's the problem with reverse delegation. And what we are looking into doing is to synthesize the records on the fly. So when a query comes in, there's going to be like a regular expression type of thing where we can say, okay, we're going to take that IPv6 address, we're going to turn it around, and we're going to create the reverse delegation on the fly for you. So you don't have to pre-populate, and you don't have to deal with dynamic DNS and those kinds of things. So that's something that's a little bit further away. Version 2.5 here is actually going to be out in just a few weeks, or maybe up to a month. So looking a little bit closer at DNS64, NAT64, we've talked about dual stack light and 6RD. Here's another transition mechanism for you. So the idea here is that you create a v6 only network. So the gray network, well, it's a little bit gray up there, but the network you can see up there is a v6 only network with a client. And when the client is requesting a service, since it's a v6, it's only going to send out the quad A. It's never going to ask for a v4 address, because it won't be able to communicate with v4. It's going to send out the quad A request to the DNS64 caching server. And the DNS64 server will go out on the internet, and it will fetch the record. If there is a quad A record out there, if the customer is going to the txv6.tf txv6tf.org site, for example, or I guess the California site is v6 enabled as well, of course, there's going to be a quad A record coming back, and the client is good to go. If there's no quad A record, what the DNS64 device needs to do is it needs to use the prefixes that are configured into the server and synthesize the record and create an IPv6 quad A, basically lie to the customer and say, yeah, there is a quad A record here, here you go. And when the client tries to connect, it's going to try to connect, and that prefix is actually routed to a NAT64 device that's going to translate between this, the internal v6 environment and go out and fetch that record, come back, and, or not the record, you know, fetch whatever type of service that the customer is trying to access. So looking again at the same thing here, what happens? A quad A comes in, the DNS64 is trying to resolve, but it comes back empty. There is no quad A. So then instead send out an A record to get an IPv4 address and then synthesize with the prefix. So 192.0.2.1 there in the picture that's underlined. If you do the math to hex, that's going to equal C0000201. So it's going to put that after the prefix and say, here's your resolution for your query. And then when the client starts connecting to that, it's not going to connect directly to the web server. Instead, it's going to go via this NAT64 device that's going to then extract the IPv4 addresses at the end there and communicate to that address and then convert it back to v6. So we created a swimming pool here on the inside that's v6 only, and we put the clients there and we do the translation. Of course, some stuff might break here, right? But this is a really good approach if you don't have v4 addresses. So if you don't have v4 addresses to do dual stack, what are you going to do? Either you need to use NAT on your v4 environment, or you're going to use NAT and do NAT64. So you need to choose between two things that suck, and you might as well just do NAT64 and be done with it, because then you only need to do one translation. You don't have to go to dual stack and then go to v6 only network. You leapfrog over this whole dual stack thing and go directly into a v6 network. The user experience with NAT64, okay, there might be some problems there, but we have problems in NAT44 as well, and especially if you add a couple of more fours there and you do, you know, multiple layers of NAT44444, you know, it's going to have a lot of issues and timeouts and stuff. So you know, again, you're choosing between two things that you know, none of them are really good, but you need to pick one of them. So stuff that's broken doesn't work, of course, right? So if you have IPv4 literals in your HTML code or something like that on your website, it's not going to work because the DNS resolution will never happen. So the browser would immediately tell you, I can't go there because I have no v4 connectivity. And there's other things like Skype and some instant messaging things that doesn't work today. But there's large service providers around the world, wireless service providers here in the US. You can, you know, if you do some Googling around NAT64, you'll find that there's wireless service providers here in the US that are going to implement this. I was in Brazil a couple of weeks ago. I talked to a service provider there, and they said, well, we're burning through 100,000 IP addresses per month, so what are we supposed to do? I mean, this is the only solution for them. There is nothing else. So there's only going to be one network to maintain here. Since you migrate to v6 directly, you don't have to deal with this dual stack issue. So you kind of leapfrog over the dual stack problem. So it's kind of, in my opinion, the IPv6 killer app a little bit, because maintaining two networks is going to be very expensive. That's where the cost with IPv6 is associated. Once you go to a v6 only network, in theory, it should be easier and simpler to manage just a v6 network compared to a v4 network. So even if you think this is a little bit of a crazy idea with DNS64 and you still say, well, you know what, I'm going to do dual stack, you know, I'm going to do 6RD, whatever. At some point, you do want to use DNS64 or some other type of translation technology. So some people might be, you know, crazy enough to do DNS64 from the beginning. And it's not that bad. So people are, you know, I've heard people saying, okay, well, only 0.48% of the top Alexa 10,000 actually do have v6 today? Well, it's not about how many sites, it's about how much traffic do those sites generate. And I can tell you, if you look at the Alexa top 10, 20, Google, you know, with YouTube and all those things, Netflix, Facebook, MySpace, Yahoo, all those big guys, they are already implementing IPv6. So once you turn on an IPv6 only network or an IPv6 network, you'll see a substantial amount of traffic already today if you can get on the whitelist from Google and Yahoo and Facebook and those guys. So let's say you see 10% network traffic today. At some point in the future, you're going to have 50% network traffic. And you have 51, once you have 51% IPv6 network traffic, your problem is no longer IPv6. Your problem is now IPv4, right? And at some point in the future, when you have 99% IPv6 traffic and just 1% IPv4 traffic, you're going to say to yourself, hey, I want to shut this v4 old legacy stuff down. And I want to put the translator in place so that if somebody really wants to reach those old sites, they can reach them. But I don't want to mess around with two networks and do this dual stack anymore. So you will need something like this sooner or later. So even if you're not crazy enough to do this from day one, this might be a transition technology that you want to look into for the day when you want to turn off your dual stack and go into a v6 only network. So the other problem that we have, and this is for dual stack networks, is that as we know, some content providers are reluctant to put a quad A record in their DNS because it breaks 0.078% of their clients. And it appears to be two main causes to this breakage. One is the browser Opera that in an early version prior to 10.4 something had a bug in there that caused a very long timeout before it retried with v4. And the other problem is that Mac OS, some version, has some problem in there, and there's also painful long timeout. So if you're using that, so the problem here is that the client thinks it got v6 connectivity, but it doesn't. So it's trying v6 first, and then it takes a hell of a lot of time before it's going to retry with v4. And this breakage, of course, the content provider says, you know, we're not going to deal with this. We can't lose 0.078% of our customer base because that's, you know, $1 million a day or whatever. So we're not going to put the quad A record in there. There's also a problem for the service provider here, because, and especially like a wireless service provider, consider the fact that you have two smartphones. One, you can get to Facebook, it takes you 1 second. The other one takes 20 seconds before it defaults back to v4 and actually render the Facebook page. That's going to be a problem for the service provider if their network is being perceived as slow because they have this underlying IPv6 that nobody really cares about, the plumbing. They just changed out the plumbing, and all of a sudden they're causing all this breakage and problem. So the service providers, they want to make sure that they don't cause any breakage for you as a client as well. So one proposed solution, and again from the folks from Yahoo, is that in the service, I think I have a slide for this, yes. In the service provider environment, so this is something that the service provider would implement in the caching DNS server, would be that if the client can prove that he can talk v6, I'm fine with giving him the quad A records back, and he can go out and talk to the IPv6 internet. But if he can't prove that he is v6 capable, I'm not going to give him any quad A records. I'm going to lie to him and say this is v4 only. And how can you figure out whether a client can talk v6 or not? The only way of figuring that out is if the query comes in over v6. Then he kind of proven to us that he can speak v6, and then it's we're good to go. We can send a quad A record back to him. So that's how that works. So we look at, you know, where did this packet come in, and we respond differently whether it came in over v4 or v6. This, of course, breaks some stuff, as always, like DNSSEC. You start lying to your clients. Obviously, DNSSEC is not going to work. It's also going to break Windows XP. Tony Hain, when he put in IPv6 support in XP, they missed the detail, and that's you can't configure a DNS server over v6 in XP. So this is not going to work. So it's going to turn off IPv6 for somebody that can't do DNS over IPv6. But it's still a solution. It might be better than nothing, and we have requests from service providers to implement those kinds of features. So I think I'm on time here, and I think actually I'm going to have maybe 5-10 minutes for questions as well. So let me conclude what I've been saying today. First of all, the first thing you need to think of is the load. You're going to double your load, so you need to look at how many queries per second am I doing today. Will I be able to handle twice the load on my infrastructure coming tomorrow when I start migrating to v6? And this might be a good opportunity to look into refreshing your hardware or software, whatever, on your DNS servers. Dual stack is the IETF recommended because that's what the RFC says, that dual stack, here's how to do it. It's the recommended mechanism to migrate to IPv6, but it's not the only one. So there's alternatives out there, such as DNS64. And for some users, such as the wireless industry, it's a very compelling way of doing things because they have fairly good control over their applications and stuff like that. So they could potentially sell IPv6 only handsets moving forward here. And we got the timeout problems with IPv6. One way of fixing that is that the quad A hack, as we call it. Also, another thing that I didn't really mention is that HTTP, and the problem with HTTP is it's related to HTTP only. There's no similar problem with DNS or SMTP mail or other protocols. It's very HTTP centric, this timeout problem. For mail, for example, it doesn't really matter if you have a 30-second timeout before your mail arrives at the receiving end. Same thing with DNS. DNS is very robust in itself, so it can figure out if something is misconfigured or if something is broken or if the v6, you can't get to that v6 DNS server. It's going to take that server away, and it's going to stop asking that server. So those are more robust protocols that are easier to migrate to v6. So once you start migrating stuff to v6, don't start with a web server. Start with a DNS and your mail server. Those are easier to migrate, and then take the web server in step 3 instead. And then finally, reverse delegation is still a problem to figure out how to do in IPv6. So with that, I want to open up for perhaps a few questions. Stan. No, it's going to be, so the question is, let me go back to that slide. The question is about the load, and if there's any new libraries that can actually ask, both for A and quad A at the same time, or is there actually going to be 2 outgoing queries? And the answer is there's going to be 2 outgoing queries. You can ask for any, which would be give me any records that you have. But you might have additional caches in the way up to the authoritative server. So if you ask a caching server for give me any, he's going to give you all the ones he has, and that might just be the A record, for example. So it doesn't work. So you need to do the multiple queries. So it's going to be twice the load. Well, I mean, as the graph implies here, you might have some NS and some MX or some other query types. But the big gray area at the bottom there is going to be that area is going to have a counterpart that's as big because everything is going to be 2 queries is going to go out. Ed? Well, there is an expired RFC from Alan Durand and Lee Howard from Time Warner Cable, and Alan Durand used to work for Comcast. So they had this problem, and they said, well, how do we solve it? And they came up with 4 alternatives. Use dynamic DNS, do nothing, use wildcards, or synthesize records on the fly. And all those 4 things that they came up with, you know, they have problems. Dynamic DNS doesn't scale. Use wildcard. It doesn't really work because there's going to be a many-to-one mapping, and you actually need a one-to-one mapping. Do nothing is going to violate an old RFC that says that you need to have this, and synthesize DNS records would be the last option, but there's no products out there for that right now. So that RFC draft actually died, and nobody ever came to any conclusion what to do. So this is still an open item. So we'll see what we can do here, and maybe come up with some clever way. Well, they do generate, and then after 5 days, when they are, you know, have done 0.00001% of the reverse delegation and filled up 200 disks, they're going to give up and say, okay, this didn't really work out for us. So, I mean, it's just impossible. It's like you need 4 billion disks with, you know, 400 gigs of storage or something like that to do the reverse, you know, to pre-populate. So it's not going to work. All righty. Any more questions? If not, I would like to hand back to Bruce and Ed, and thank you.